Welcome to Hoboken, New Jersey, home of Frank Sinatra and the birthplace of baseball. In my walkSTEM, we will be visiting some iconic Hoboken locations and learning about physics along the way. Our first stop is the Castle Point Skate Park, located on the Hudson River. Many people walk, jog, or bike along the Hudson River, and there are amazing views of the Manhattan skyline. At this stop, we will be learning about the concept of conservation of energy by watching the following video. You will notice that the skateboarder's velocity isn't constant throughout his time on the ramp. At which point would the skateboarder have the fastest velocity? Conservation of energy states that the energy in a system stays the same unless acted on by an outside force. So, in other words, the energy in the beginning is the same as the energy at the end. When the skateboarder first goes down the ramp, starting from rest, he has gravitational potential energy, and that is the energy stored as a result of his vertical position. As the skateboarder travels down the ramp, the gravitational potential energy is converted to kinetic energy. And at the middle of the ramp, where there is no height, he reaches his maximum kinetic energy. If the skateboarder had continued going up and down the ramp from side to side, he would have reached his maximum gravitational potential energy on either side of the ramp and reached his maximum kinetic energy at the middle of the ramp if there was no friction acting on the skateboarder. Kinetic energy and velocity have a directly proportional relationship. So, where the maximum kinetic energy is, the maximum velocity would also be. So the maximum velocity is reached at the center of the ramp. Our next stop is Sinatra Soccer Field, also located on the Hudson River. And you guessed it, it is named after Frank Sinatra. At this stop, we will be learning about friction by passing a soccer ball on a turf field. Notice how the soccer ball rolls to a stop. Why would a soccer ball slow to a stop after being kicked, assuming it does not hit another object? Friction is the force that resists motion when the surface of one object comes into contact with the surface of another. In this example, the surface of the soccer ball is coming into contact with the surface of the turf. When you kick a soccer ball, you apply a force to it, causing it to accelerate in the direction of the force. But friction acts opposite to the direction of motion, causing it to slow to a stop. The frictional force is equal to mu k, which is the coefficient of kinetic friction, times the normal force, which, unless the object is on an incline, is equal to mass times gravity. A higher value of mu k results in a higher frictional force, and a lower value of mu k results in a lower frictional force. Turf has a lower value of mu k than grass does, which is why, if you've ever played soccer before, your coach would generally advise you when you're playing on grass to kick the ball harder because the ball would come to a stop faster. Our final stop is the tennis courts located on the Stevens Institute of Technology. Here, we will be learning about free fall motion by tossing a tennis ball into the air. Watch the tennis player throw the ball into the air. What would the ball's velocity be at its maximum height? And how would the magnitude of its velocity change once it returns to its original position? Before we answer the question, it's important we understand what gravity is. Gravity is the force that pulls all things towards the center of the earth. When an object is in free fall, like the tennis ball being tossed, the only force acting on the ball is gravity, and the acceleration is negative 9.8 meters per second. The motion of the tennis ball in free fall can be drawn as an upside-down parabola. The velocity of the tennis ball is in the positive y direction in the beginning. Then, at its maximum height, the velocity is equal to 0 when it turns. After that, the tennis ball falls back to the earth and has a velocity in the negative y direction. Thank you for watching and visiting Hoboken.